Imagine for a moment that you're holding a teaspoon. Now imagine that this teaspoon weighs 6 billion tons, the equivalent of 1,000 Great Pyramids of Giza, concentrated in a space smaller than a coin. Does that sound impossible? Welcome to the world of black holes, where reality itself is taken to the extreme. Hello, cosmic explorers. I'm your guide on this journey through the Cosmic Frontiers channel, where we unravel the universe's mysteries together. And today, we're rediving, literally, into the most extreme and fascinating phenomenon in the cosmos: black holes. If you're new here, a very warm welcome to our community. Don't forget to subscribe and hit the notification bell, because we're on an epic mission towards 1,000 subscribers, and each one of you is fundamental to this journey of discovery. But before we continue, answer me in the comments. What do you think would happen if you fell into a black hole? Keep that answer in mind, because by the end of the video, you'll have a completely different perspective. So, what exactly is a black hole? The simplest answer is, imagine the densest object you can conceive, and then multiply that density by trillions. A black hole is a region of space where gravity has become so intense that not even light, the fastest thing in the universe, can escape. To understand this better, let's use an analogy. Imagine a tightly stretched trampoline. If you place a tennis ball in the center, it will create a small dip. Now, if you place a bowling ball, the dip will be much larger. A black hole would be like placing something infinitely heavy. The dip would be so deep that anything that rolled nearby would simply plunge in without return. But how can something like this exist? The answer lies in the life and death of stars. When a massive star, at least 20 times larger than our Sun, reaches the end of its life, something extraordinary happens. For billions of years, this star maintained a perfect balance: nuclear fusion in its core pushing outwards, and gravity pulling inwards. But when the nuclear fuel runs out, gravity wins dramatically. In a matter of seconds, the star's core collapses in on itself with such intense force that protons and electrons are crushed together, forming neutrons. If the star is massive enough, not even this pressure can stop the collapse, and the core continues to contract until it becomes a point of infinite density, a singularity. Now, here's where things get really interesting. Albert Einstein, with his theory of general relativity, predicted the existence of black holes in 1915, but he himself doubted they could exist in reality. Ironically, his own equations perfectly described these impossible objects. The term black hole was only coined in 1967 by physicist John Wheeler. Before that, they were called dark stars or frozen stars. But the name stuck because it perfectly captures the essence of these objects. They are literally holes in the fabric of space-time, and they are black because they absorb all light. Let's talk about the anatomy of a black hole. First, we have the event horizon. This is the point of no return boundary. Once you cross this invisible line, there is no force in the universe capable of bringing you back. The size of the event horizon depends on the black hole's mass. For a black hole with the mass of our Sun, the event horizon would only have a 3-kilometer radius. But here's a fact that will surprise you. If you were falling towards a black hole, two very strange things would happen simultaneously. To you, everything would seem normal. You would cross the event horizon without even noticing. But for someone observing from afar, you would appear to freeze at the event horizon, your image becoming redder and redder until it completely disappears. This happens because of gravitational time dilation. Time literally passes more slowly near intense gravitational fields. It's as if the black hole were a cosmic time machine. And if you think that's strange enough, wait until you hear about Hawking radiation. Stephen Hawking discovered that black holes are not completely black. They emit a very faint radiation. Paradoxically, the smaller the black hole, the hotter it is. A black hole with the mass of Earth would have a temperature of only 0.02 Kelvin, colder than empty space. But a microscopic black hole would be hotter than the Sun. Now, let's talk about the different types of black holes. We have stellar black holes, formed by the collapse of massive stars, which can be 3 to 20 times the mass of the Sun. Then we have supermassive black holes, true cosmic monsters that live at the center of galaxies and can be millions or billions of times the mass of the Sun. Our own galaxy, the Milky Way, has a supermassive black hole at its center, called Sagittarius A. It has 4 million times the mass of the Sun and is 26,000 light-years away. Fortunately for us, that distance keeps us perfectly safe. But how do we know black holes exist if we can't see them directly? Excellent question. Astronomers are like cosmic detectives. They observe the effects of black holes on their surrounding environment. When a black hole is near a star, it can steal material from it, creating a disk of superheated matter that glows intensely before disappearing forever. And in 2019, something historic happened. The Event Horizon Telescope team, led by the brilliant scientist Katie Bootman, managed to capture the first real image of a black hole, M87*, located at the center of galaxy M87, 55 million light-years away. It was like taking a picture of a coin on the surface of the moon. This image confirmed decades of theory and showed exactly what Einstein had predicted: a bright ring of superheated matter around a perfectly black circular shadow. It was a moment of triumph for human science. Black holes are also responsible for some of the most energetic phenomena in the universe. When matter falls into a supermassive black hole, it can create jets of particles that extend for thousands of light-years, traveling at speeds close to that of light. These jets can be seen from billions of light-years away. But perhaps the most fascinating aspect of black holes is how they challenge our understanding of physics. At the singularity, the center of the black hole, our laws of physics simply break down. Density becomes infinite, space-time curves infinitely, and concepts like before and after lose their meaning. This leads us to one of the biggest questions in modern physics: what really happens inside a black hole? Some theories suggest that the singularity could be a portal to other dimensions or even other universes. Others propose that information falling into a black hole is somehow preserved, leading to Hawking's famous information paradox. And here is something that will blow your mind. Some scientists theorize that our own universe might be inside a gigantic black hole. It's a speculative idea, but it shows how these objects challenge our perception of reality. Black holes may also be the ultimate fate of the universe. Due to Hawking radiation, all black holes eventually evaporate, but this process would take longer than the current age of the universe, multiplied by trillions of times. At the end of time, when all stars have burned out and all matter has dispersed, black holes may be the last remaining objects in the cosmos. But don't worry, cosmic explorers, this is so far in the future that it's practically irrelevant to us. What matters is that black holes continue to be natural laboratories where we can test the limits of physics and expand our understanding of the universe. So, coming back to the question I asked at the beginning, what would happen if you fell into a black hole? Well, technically, you would experience something called spaghettification. The gravitational difference between your head and your feet would be so great that you would be stretched like a piece of spaghetti. Not exactly a pleasant experience, but from a scientific point of view, you would be participating in the most extreme experiment possible, testing the limits of physics under conditions that we can never replicate on Earth. So, cosmic explorers, what did you think of this journey through black holes? Did I manage to change your perspective on these fascinating objects? Tell me in the comments which facts surprised you the most. If you enjoyed this video, don't forget to leave a like. It really helps the algorithm show our content to more people who are passionate about the cosmos. And if you haven't subscribed yet, now is the perfect time. We are growing rapidly towards 1,000 subscribers, and each one of you is essential to this journey. Activate the notification bell so you don't miss any of our upcoming videos. And while you're at it, let me know in the comments, what cosmic mystery would you like me to explore in the next video? Perhaps wormholes, dark matter, or maybe the search for extraterrestrial life. Share this video with that friend who loves universe mysteries. Let us spread the fascination for science together. Remember, we are a community of cosmic explorers, united by curiosity and the desire to understand our place in the universe. Every question you ask, every comment you leave, every like you give, brings us closer to unraveling the secrets of the cosmos. Black holes teach us that the universe is far stranger and more wonderful than we ever imagined. They are humble reminders that we still have much to learn, much to discover, and much to marvel at. Keep questioning, keep exploring, and keep looking at the stars with that spark of curiosity that truly makes us human. In the next video, we will explore another phenomenon that challenges our understanding of reality, and I promise it will be equally fascinating. Until then, keep looking up at the stars and questioning the mysteries of the cosmos. Thank you for being part of this journey, cosmic explorers. The universe is vast, mysterious, and absolutely extraordinary, and we're just beginning to unravel its secrets.